Alright guys, today we're looking at the Chemistry 2 question. Find the pH of 1.85 grams of HCN, also known as hydrogen cyanide or hydrocyanic acid, of molar mass 27.02 grams per mole, dissolved in 3.5 liters of water. So up front there are going to be three things that we're going to want to know, and these three things is going to be the Ka of hydrocyanic acid, the formula for finding Ka, and the fact that pH is equal to negative log base 10 of the concentration of H plus ions. So the tricky part in this problem arises in the fact that hydrocyanic acid is a weak acid and it does not 100% dissociate when added to an aqueous solution. So the first step to solving this problem is going to be to find the concentration of hydrocyanic acid in our 3.5 liters of water. To do this, we're going to start out with our mass. It's 1.85 grams of hydrocyanic acid. We're going to divide that by the molar weight, which is 27.02 grams per mole HCN. So when we do this, we find that we have 0.06846 moles of hydrocyanic acid. Now from here, once we have to calculate molarity, we have to take our number of moles, which is going to be 0.06846 moles, divided by our total volume, which is 3.50 liters, and that is going to give us 0.01956 molar concentrated solution of hydrocyanic acid in water. So now this is our concentration of hydrocyanic acid in our aqueous solution. Now with this being an acid, it is going to donate a hydrogen into that aqueous solution. So we're going to start out with HCN, and that is going to give us an H plus ion in water and this Cn minus ion in water. Now, as you can see, for every 1 mole of this that we add in, every 1 mole of hydrocyanic acid, we're going to end up with 1 mole of H plus ions and 1 mole of HCN. So, since these have a 1-to-1 ratio, our concentration of H plus ions is equal to the concentration of Cn minus ions. So this is where that tricky part I brought up earlier comes in, and we're going to start out by saying that Ka is equal to the concentration of our products times divided by the concentration or reactants. So these two are going to be our reactants up here. These are going to be our products up here. This is going to be our reactant. Now, notice that these two concentrations here I said are equal to each other. So to simplify this problem, I'm just going to call both of these x. So all we'll have to do is solve for x. So our Ka is going to be equal to x times x divided by the concentration of our reactant, which from up above, the concentration of our reactant is 0.01956 molar. And our Ka from up above is Ka of hydrocyanic acid is 6.2 times 10 to the negative 10. So now we just substitute this value in right here. We're going to have 6.2 times 10 to the negative 10 is equal to x squared divided by 0.01956. And now to solve this, we're just going to multiply both sides and then take the square root of both sides. These are going to cancel, our root's going to cancel, and we're going to say that x is equal to our concentration of H plus ions, which is equal to 3.48241 times 10 to the negative 6 moles. And the last bit of information that we needed from up above was that pH is equal to the negative log base 10 of our concentration of H plus ions. So we can just simply plug this part into a calculator here. We find out that pH is equal to roughly, it's negative log base 10, 3.48241 times 10 to the negative 6, which gives us about 5.45, I want to say it was 5.458, and that is your final answer. If you guys have any questions, let me know in the comments, and I'll be happy to give you any further explanations.